Okay, seventh grade, we're starting a new unit now on data analysis. This is one of my favorite units because it's very real world and it's all about statistics, which is one of my favorite things in math. So, in order to truly understand statistics, we have to first understand some of the vocabulary. So, you should have your vocabulary sheet printed off or written down on a piece of paper. And so, let's start. You may have to pause to keep up with me and write these things down. So, population. A population is a group of people or objects. Generally, the population, you're trying to collect data about a population. And so, for example, if I wanted to know about the favorite pop of the seventh graders at EDCO, then the seventh graders at EDCO is my population. If I wanted to know about the favorite pop of seventh graders across America, then seventh graders across America is my population. And so I have a quick picture here, like if this is my population, the X's represent that. All the X's on the page is my population, whether it's seventh graders at EDCO, seventh graders in America, every woman in the world, that's your population. You have to decide what it is you want to gather the information from or about. Okay, and then a sample, or you'll hear me say sample size, those words are interchangeable, is simply that. It's part of the population. It's not the whole population. For example, if I want to know the favorite pop of all the seventh graders at EDCO, that is very easy for me to get that information about my entire population. I have access to all the seventh graders at EDCO. There's only 30 to 40. I can simply go ask them. However, if I want to know about the favorite pop of all the seventh graders in America, I cannot physically ask every seventh grader in America. That's not going to work. So I have to do a sample, which means that I have to ask some seventh graders, okay? And I want my sample to be a good one. So a sample is when you are doing just part of your population like that. I'm just picking some of them. And then I'm going to use that data and extrapolate it and make assumptions about the entire population based on that data. Now, would a good sample of seventh graders across America just be seventh graders at EDCO? No. So in order to have a good sample, you do have to make decisions like you want to make sure everyone's represented. So in this case, I'd probably want to make sure I have equal numbers of females and males that I'm asking. I probably want to make sure that I have a few seventh graders from every state. That way we're not just in the Midwest or just the South or things like that. You probably want to make sure you're asking the different ethnicities, different races, different urban versus rural. You want to make sure that you are getting kind of an equal representation of everyone when you are doing sampling. If I just ask seventh graders at EDCO, that is not a very good representation of seventh graders across America. Okay, so you do want to make sure that that is your sample. One way to do that is to do what we call a random sample. So a random sample is each member of the population has an equal chance of being selected. Okay, so if I wanted to find out about seventh graders across America, I'm not going to predetermine I'm going to ask just these people. One thing you might do is I could email all of the schools in America and ask them to ask their seventh graders. I could pick randomly and alphabetically. If I had a list of seventh graders, I could pick every 100th seventh grader in America. I could, if listed alphabetically, I could pick every fifth school district in New York, and then every fifth school district in New Jersey, and then every fifth school district in Iowa, and then it's more random, and everyone has that chance of possibly being selected in order to be interviewed. So that's random sampling, and you want to make sure that you are doing that truly random. So if you're asking a question, let's say your population is the entire student body at EDCO. The entire student body at EDCO isn't. You could get the whole population, but it is a little more difficult. So if I want to know the favorite pop of every student at EDCO, and I don't want the whole population, I just want to sample, going to junior high lunch and asking is not very random. High schoolers cannot go to junior high lunch, so I'm completely leaving them out. If I stand at the door from 7:30 to 7:45 and ask those people who come in the door, now it's a little more random because that could be a junior high or a high school or a male or female, but I'm leaving out all the students who ride the bus because our route buses don't get here till 7:50 and our Colesburg kids don't get here till 8. So I have to do it at a time when no one would be left out. Now, granted, if a kid is homesick for the day, they had a chance of being here, that's kind of a different story. So if I sent an email to all of the EdCo students and said, okay, I'm going to accept the first 100 responses, that's more random because everyone has a more equal chance of getting to be part of my sample size. Okay, so then a biased, how I ask the question is important. What is your favorite pop? So a biased question is when it makes some answers appear better than others. So for example, if I ask, is your favorite pop the very delicious Coke, or do you prefer the yucky Pepsi products? Pretty obvious. I'm definitely putting a bias on that. Do you like wonderful classic music or that headache-causing rock music? If you ask questions like that, they're definitely, people know where you stand on the issue, and they may give you an answer either to make you happy or just to make you mad. So you want to make sure that your question is what we call fair. So fair on the back is simply that, it's not biased. What is your favorite pop? Of Mountain Dew, Pepsi, Coke, Dr. Pepper, which one would you pick? You keep it very simple to make sure that your questions are not biased or unbiased. Inference. So one of the things we're going to do is once we collect a bunch of data, we're going to make an inference. An inference is make a prediction or a conclusion based on data or reasoning. That last word is reasoning, based on data or reasoning. So if I collect a bunch of data, let's say I did do a sample of the entire United States, all the 7th graders in America, and I got back that Mountain Dew was chosen 90% of the time, I could, as long as I had done a fair question and I had done true random sampling, I could go ahead and make an inference that that's probably true of most of the population. Even though I didn't ask the entire population, I could extrapolate that out, okay? A box and whisker plot, I'm not really going to give you a definition. I'll kind of show you a quick picture of what a box and whisker plot looks like. When we get to our project we're going to do together, I'm going to go more in depth. But a box and whisker plot basically is a way to plot all of the data that you can collect. Okay? And this is the data you're going to collect: the mean, median, mode, and range. You've probably heard of these before. The mean is your average. Okay, so what is the average of that? So if you collect data, and so in this case, your answer wouldn't be a pop. It may be, how many ounces of water do you drink a day? Maybe that's the data you're collecting, and you're asking all of the kids at EdCo, how many ounces of water do you drink? You're going to find that average number. Okay, remember, you add up all your numbers and divide by how many people you asked to get your average. That's called a mean. Median is your middle number. So if I take all my numbers and I write them numerically in order from smallest to biggest, so if I have 50 numbers and I've written them in order, the median is if I come into the very middle. What number is smack dab in the middle of my data? That's your median. If you think of the median of a highway, that's the middle of your highway. And then mode is the number that occurs the most. So if I've asked 50 people how many ounces of water they drink a day, and 10 out of the 50 people said 100, and that's the most that's occurred, then 100 is my mode. It is possible to have more than one mode. I could have 6 people say 75 and 6 people say 100, so I have 2 modes. It's also possible to have no mode, which means no number was ever repeated or is any more than any other. Okay? And then a range. Again, if like the median, you line your numbers up from smallest number to biggest number, you simply subtract your maximum minus your minimum. So maximum being your biggest number minus your minimum. So if the biggest amount of water people drink is 200 and the smallest is 10, my range is 200 minus 10, which is 190. Okay? Then interquartile range, which I'm going to call IQR, is an upper quartile minus your lower quartile. You don't know those terms yet. We will learn those when we go to do the project, but basically your upper quartile is where 75% of your data falls, and lower quartile is where the 25% mark is. So think of median as kind of the 50% mark of your data. Upper quartile is 75%, lower quartile is 25% mark of your data. You would subtract those. That's called an interquartile range. So that is your vocab there. And then we just have a couple more. We have our measures of central tendency. Those are your mean, median, and mode, because they talk about the center of the data. And then your measures of spread or your variability, that would be your range and your interquartile range. And we will learn more about all these vocab words as the unit progresses.